Go. Yay. Go. Go, team, go. Oops, now we're off. See? Oh, well, see, now we're way off here. Get that back there. All right, so today we are going to graph lines. Okay? Yay! Woohoo! Exactly. Twirl that hair. Okay? All right? So, now, a couple of things about the graphs, your final product on a graph. Okay? First thing, I would like you to right now find something on your person or in your bag or on your desk that you could use as a straight edge because all lines are straight. Okay? And so we want our lines to be straight. Okay? Okay? So what I see from peering around the room is I see most people grabbing an ID or a license or a credit card or something like that. And that's awesome. That's great. Okay? I see some people using the edge of a folder. I see some people using that hard edge on the cover of their planner. Okay? That's great. I saw one person using a cell phone. Okay? All great. Okay? All great. So you all have something that's straight. Okay? That you can use as your straight edge. Okay? Because what I want is, so if this purple line here on this picture is what my graph is supposed to look like. What I don't want, because you guys are all better than this, I don't want that. Okay? Because that's just lazy. Okay? All right? I want you guys, my bar is up here. Okay? My bar is high. I set my bar high. Okay? Right? That's where I want you guys to be. I don't want you guys to be average. I want you guys to excel. Okay? That's my goal. That's where my bar is for you guys. Okay? And I think everybody in this room can achieve that bar. Okay? Whether it's drawing lines, whether it's showing your work, whether it's doing math, whether it's being a good person. My bar is high for all of us in this room. Okay? So that's one of the things that we can do. Okay? Second thing that I would like to draw your attention to is because I know where we're going with this. Okay? One of the things that I've seen is people will draw their lines like that. That big. Okay? They'll plot like a point, and then they'll plot another point, and that's as far as their line goes. Okay? And yeah, that's great. You drew the line. Okay? But where we're going with this, we're going to end up going into systems of equations. And that's going to be in the next chapter. And one of the ways to solve systems of equations is by graphing. And so you're going to graph multiple lines on one graph, and you're going to see where they intersect. Well, if your lines look like that, I can't tell you where those intersect. Okay? So the other habit that I want you to get into, first habit was I want you to use something that's straight to draw your lines. The second habit I want you to get into is I want you to draw your lines all the way across your graph. Okay? So that those arrowheads are on the outside of your graph that you do. Okay? Because when we get to systems of equations, then when they cross, you will see where they cross, if you will all the way across. Okay? So those are the two things as we go forward that I want you to get in the habit of doing. Okay? Let's do this now. Oh, yeah. Okay? So, there are 3 different types of equations of lines. Okay? The first form, if you will, is something called the slope-intercept form of a line. Y equals mx plus b. You all have seen it. You all have used it. Okay? It's the most common. Whenever I say, what's the equation of a line? 9 times out of 10, people say y equals mx plus b. Okay? Second type, or second form, if you will, is something called the point-slope form of a line. Okay? The point-slope form uses just that. It uses a point that's on the line, and it uses the slope of the line to come up with the equation. And lastly, now I got to go through and I got to change this because I didn't scroll down far enough this morning when I was looking at it. We'll make that. Then we'll bring this up. We'll bring that up. Is something called the standard form of the equation of a line. Okay? And that's ax plus by equals c. Now, standard form comes with it 2 conditions. The other forms don't have conditions, but standard form has 2 conditions. The first condition is there is no fractions or decimals Okay, that's the first condition of standard form. No fractions or decimals. Second condition, A is positive. Using the 3 forms, 9 times out of 10, your answer will be in point-slope form, or excuse me, slope-intercept form, I should say. 9 times out of 10, your answer will be in slope-intercept form. Okay? And probably not even, well, when it's all said and done, probably 9 times, probably about 8.5 times out of 10, it'll be in slope-intercept form. The other time, your answers will be in standard form. Okay? Point-slope form is it's kind of where you start. Okay? It's how you get to the other forms. Okay? That's the first thing you're going to do is you're going to find the slope. Second thing you're going to do is you're going to use the point-slope form. And then depending on which form you have to go into, if you're going up to slope-intercept form, you just solve it for y. If you're going down to standard form, you get x and y both on the same side, and then you make sure that there's no fractions and that a is positive. Okay? But we'll get more into that next week. Okay? All right? So that's those. Now, what I would like to talk about is I would like to talk about different ways that you know of to solve or to graph lines. Okay? So I'll give you a couple of minutes to brainstorm with you, your partner, your shoulder partner, whoever you want, and then we'll come back and we'll chat about what it is to graph lines. Good thing we were talking about what you're doing this weekend instead, though, then, huh? No? No? Okay. Give me one way to graph a line. What? So how would I find points to plot? Okay. For what?
Maybe like using rise over 1 for that.
Okay. Close. We're kind of mixing methods here. Like how do I get points to plot? Let's go back to plotting points. Using a T-chart, okay? So one method is we can use a T-chart. We've all done it before. Walk me through what you do to make yourself a T-chart. Okay, then what? We've all done it before. What do I do when I'm making a T-chart?
So equations.
Not yet. No. Very first thing you do when you make a t-chart. After you draw the T, what do you do?
The numbers.
What numbers?
X and Y. You gotta write it on top, right?
Okay.
That's the part.
Okay, that's so we made our T. Okay, then what do? What? Say it. You pick some X's, right? Okay, so first thing we gotta do after we make the T is we pick some X's. How many X's should we pick?
3 or 4.
So at least
Yeah,
3,
at least
right?
3.
At least 3. So we should pick 3 plus X values. Oops, that's a bad X. Now erase that, and we'll just start over. Then what are you going to do? After you pick those X values, now what do you do? No, we don't. You can't pick the Y's.
You plug it into the equation.
And do what?
Solve for Y.
Solve for Y, for all the individual ones, right? Then what?
Add it to your T-chart. Oh,
So you put
did?
so you put the Y's in your T-chart then, right? Okay, now what? Now we can plot our points, right? Okay, because now we have at least 3 X, Y values that are points. Now what would we do? Now we draw our line. Yep, we'd use our straight edge. We draw our line all the way across the graph. Yep. Okay, so that's the T-chart method. Love it. Yeah? You may not use it. You may use it. That may be your go-to jam. Okay? That's you. I'm giving you options. Okay? It's what you do with those options. We're all going to end up together in the same location. We may all take different routes to get there, but we're all going to end up in the same spot. Okay? Give me another method that you guys came up with. Give me a second way to graph a line.
Mapping.
What?
Mapping.
That's not really going to be a way to, that's just a way to represent the relation. That's not going to get me into actually graphing a line. Brett,
Histogram.
that's not going to get me a line. No.
What about a scatter plot?
No, that's all different ways to represent data. Yeah.
Replace your X and Y with 0.
So I could use the intercept method. We learned that yesterday. Yep. Okay. So intercepts. Okay. So what am I going to do in the intercept method? We learned this yesterday. What do I do with the intercept method? Okay, it's kind of like a T-chart, but what am I specifically doing? Zero in for what?
Either X or Y.
Okay, so let's say we plug 0 in for x, that would give us what? If I put 0 in for x into my equation, that gives me the
X-axis?
nope, y intercept. Yep. Okay, so that gets me the y-intercept. Okay. Then I plug 0 in for y, and that gives me the x-intercept. Okay. Then what do I do? What do I do? I plot those 2 points. And then I draw my line. Yep. Okay. In terms of ways to graph a line, okay, intercept method is good. The only downfall with the intercept method is it might not always come out to be a nice, neat intercept. You might have a fractional intercept, okay? But still good, okay? You can still, I think you can handle the intercept method, okay? Still missing the way that you guys all probably graph lines. Okay? The method, your go-to method is what we're missing yet. Yeah? What do you got? Slope intercept form. Yep. Okay. Your go-to method is probably using the slope intercept form. And the slope intercept form is y equals mx plus b. Okay? That's probably your method. Your go-to method is you're going to solve your equation for y. Okay? All right. From there, what can you do? How would I go about graphing using y equals mx plus b? What do I do first? Find the y-intercept. Okay. So I'm going to plot that point, right? What point is the y-intercept? B is a number, in this case it's a number, so really it's just a letter, but B is a number. I need it to be a point, though. Not 0, comma y. Not 0, comma x. No. In y equals mx plus b, the y-intercept is the point so let's say it was y equals 14x plus 7. What's the y-intercept? Don't say 7, because 7's a number. 0, comma 7. If it was y equals negative 2/3 x minus 3, what's the y-intercept? 0, comma negative 3. If it's y equals 5x plus 1, what's the y-intercept? 0, comma 1. If it's y equals mx plus b, what's the y-intercept? 0, comma b. Good job. Okay, so I plot that point. The y-intercept is a point. Okay, so I need to write it as a point. Okay, all right. Logan, you'd find it more interesting today if you were off of your phone. Okay, all right. So that's the first thing I do. What's the next thing I do? After I plot that point, what's the next thing I do? So now I got a dot on my graph somewhere on the y-axis. next thing that we do. Next thing we do.
Do you have to solve the B?
Nope. We already used B.
Find the slope.
What?
Find the slope.
And how am I going to use the slope?
What do you mean, how are you going to use it?
Well, like I know the slope is m in my equation, right? So how am I going to use that on my point that's at B, or at 0, comma B?
It tells you how much to like
Rise and run. Yep, exactly. So I'm going to then use the slope. How many more points should I plot?
4 or 3.
More than 2?
Yeah.
At least 2? Okay. Maybe at least 1 in each direction? Okay. All right. Love it. Then what?
Draw the line.
Draw my line. Okay. Those are your 3 main ways. Okay. In terms of order that you're probably going to actually do them, you're probably going to do number 3 the most. Okay. Number 3 is going to probably be your go-to jam. After that, more than likely, number 1. Okay. And then you would probably do the intercepts the least, because it's not always, like I said before, it's not always going to come out to a nice, even intercept. Okay? All right, let's graph some lines. Okay? So, I want to find the slope and the y-intercept and then graph the equation. Okay? One of the things that will get you farther in this class is if you read the directions. Okay? Don't just assume that you know what's being asked in the problem. Okay? So there are 3 answers to this particular problem. Okay? I'm asking you for the slope, I'm asking you for the y-intercept, and I'm asking you for the graph. If you just give me the graph, you've only got 1 out of the 3 things right. Okay? Right? If you just gave me the slope and the y-intercept, you'd have 2 out of the 3. Okay? So, it's in y equals mx plus b form. What is the slope of this line? Slope of this line. What?
Down 2 over 1.
Slope is a number that you gave me the rise and the run. -2. So just -2 would be the slope. And so I'd write that as m equals -2. Okay? When I go to use it on the graph, then I'm going to go down 2 and write 1. Yep. Okay? What is the y-intercept of this graph? 0, 3, because the y-intercept is a point. We're giving it in point form. Okay. So now, going to make the graph. I go over to my graph and I plot the point 0, 3. So I go from the origin, I go up 3 to my graph. Boom, there it is. Then, as Luke told us, we're going to go down 2 from that point and right 1. Down 2 and right 1. Down 2 and right 1. Down 2 and right 1. If I don't like down and to the right, I can always go up and to the left. Up 2, left 1. Up 2, left 1. Okay? Then I am going to draw my line all the way across the graph so that my arrowheads are on the outside of my graph. And that's that. Okay? Please find the slope, find the y-intercept, and the graph. of this equation. Again, I don't care how you go about doing your particular problem, we'll end up in the exact same location with the exact same answers. So I would first subtract 2x from both sides, because my go-to jam is putting it in y equals mx plus b form. Then I would divide everything by 3. So that's going to be y equals negative 2/3 x plus 5. That tells me then that the slope of my line is negative 2/3. That tells me that my y-intercept is at 0, 5. And that then I need to slide on down. And so then I'd go up 5 right there. Down 2, right 3, down 2, right 3, down 2, right 3, up 2, left 3, gives me my line, and shabam, there it is. Find the x and y intercept, then graph. So this is basically asking you to graph it using the intercept method. Okay? So since we haven't done an intercept problem yet, to find the x-intercept, that is where y is equal to 0. So this is going to be 2x minus 6 times 0, and that's going to equal negative 12. So that goes, this whole term goes away. So that's 2x equals negative 12. So that gives me x equals negative 6. So my x-intercept is negative 6, 0. 1 and 2 and 3 and 4 and 5 and 6 right there. Okay. My y-intercept is where x is equal to 0. So this is going to be 2 times 0 minus 6y equals negative 12. So this part goes away. So that just becomes negative 6y equals negative 12. Divide both sides by negative 6. Y equals positive 2. So that gives me my y-intercept of 0, 2. Oops, that should have been in. Come on now. There it goes. That color. OCD coming through. 1 and 2. There it is. And then again, I draw my line all the way across so that it's outside. Okay? There are two special kinds of graphs. The first special kind of graph is the graph of a horizontal line. And that is going to be y equals some number. Okay? If I wrote this in slope-intercept form, it would be y equals 0x minus 1 in this particular case. Okay? So that tells me that my slope here is 0 and that my y-intercept is the point 0, negative 1. On a graph, it looks like that. Okay. The other special kind of graph is a vertical line. And those will always be of the form x equals some number. One and two and three and four, so that one's right there. Okay. Those will always have a slope of undefined, and they will always have a none y-intercept. Even if you're graphing the line x equals 0, the y-intercept is still none. Okay? Because we can't, it doesn't cross the y-axis. It is the y-axis. So even if the line x equals 0 is graphed, you still do not have a y-intercept. Okay? Graph that one using any method that you choose. My go-to jam, divide by -8. Y equals -1/2 x minus 2. Okay. So that tells me that I am going down 2, and then from that down 2, from that point 0, -2, if you will, I'm going to go down 1 and right 2, down 1 and right 2, down 1 and right 2, or up 1, left 2, up 1, left 2, and all the way over. Okay. Side note: up and right. Oops. Let's choose that one then. Up and right are the positive directions on a graph. Down and left are the negative directions on a graph. Okay? So if you have a negative slope, you can only go in one negative direction. If you go in two wrongs, making a right, or two negatives, make a positive. Okay? So if you go down and left, that's positive because of the division. Okay? Same problem, just quick shown in intercept method. Okay? So if I set y equal to 0, then I've got 0 equals 4x plus 16. So then that gives me -16 equals 4x. -4 equals x. So that gives me an x-intercept of -4, 0. 1, 2, 3, and 4, which is right there. And then x equals 0, -8, y equals 16. Y equals -2, which again was that one right there. Okay. T-chart method, just plugging in and getting out numbers. Okay. There is your homework for this evening. I remind you that on Monday's class, or during Monday's class, you have sections 2.1, 2.2, and 2.3 due. Remember that I changed the homework to 2.2. It's different than what was on your note sheet for section 2.2. Everybody, with the exception of those 4 or 5 people that left early in the first class, should have that change. Okay?